Okay, so basically, what we did till now was the understanding of all these different cases based upon those kind of charges which were point charges, isn't it? We did like that. Now, the point is very, very clear that if we are taking point charges, then it is easy to do the calculation and all things we can discuss. But the cases changes, means the understanding or different kinds of arrangement actually changes when we have those kind of charges which are basically present, but they are present on some kind of a continuous bodies. On which kind of bodies? So basically we have two kind of nature of the bodies. One is called as discrete nature and another one is called as continuous nature, isn't it? So in discrete nature, what happens is our particles are there, means our particles are there, but they are actually placed far apart, isn't it? So there is no interaction between each of them. Means if you consider two particles, then there is very less interactions with respect to themselves. So these kind of situations in which the particles are placed far apart, we call it as discrete kind of system. But then there comes the cases like if you consider a rod, if you consider a sphere, or if you consider some kind of let's suppose ring, all these kind of bodies are there in which these particles are there, but they are very closely placed, isn't it? And when they are closely placed, what actually happens is the interaction between the particles start to happen, isn't it? Like two particles can interact easily, and they actually changes the concept of whole electric field and all. So this is why today, like our understanding, we will try to develop our understanding based upon this nature, like discrete nature. Till now, we have discrete all the discrete natures, okay? But right now, we are going to discuss about the continuous nature. किसके बारे में बात करेंगे अपन? कंटिन्यूअस नेचर के बारे में, जिसमें पार्टिकल्स क्या होते हैं, प्रेजेंट रहते हैं क्लोज पैक स्ट्रक्चर्स में, ओके? So look over here, let's suppose if I have continuous bodies, the continuous bodies are defined like earlier also we have discussed. The continuous bodies are taken in three different ways, okay? They are taken in how many ways? Three different ways. The one we call it as one dimensional body, isn't it? Second one we call it as two-dimensional, and the third one we call it as three-dimensional. Is that clear? So we have three different kinds of bodies. One is one-dimensional, second is two-dimensional, third one is three-dimensional. One-dimensional bodies are also known by a name of linear bodies. Two-dimensional bodies are called as surface kind of bodies. And third type, three-dimensional bodies are called as volumetric bodies. Are able to get me? The main difference is like in between all of these three is that when we are considering a linear body, what actually happens is that the bodies are packed in such a way that the placements of particles are in only one direction. In which direction? And that is why we call these kind of bodies as which kind of bodies? Linear. Because the placement of particle is in only one direction. Are you able to get me or not? Similarly, if I consider two-dimensional bodies, what actually happens is, in this, what will happen, you will see that the particles are arranged first along the direction of length. Second, they will be also arranged along the direction of breadth at the same instant of time. Means, I can arrange the particles in two different directions at the same instant. and then we, if the surface, the particular arrangement which we get out of it, or the body which we get it out of it, is called as surface kind of bodies. So surface kind of bodies are those bodies in which the placement of particles is in two directions at the same instant of time. Are you able to get me or not? Similarly, if I arrange all the particles along the three directions, x, y, z axes, then I'll get a definitely a volumetric kind of body or not. So volumetric three-dimensional bodies are those bodies in which the placement of particles are done along three dimensions at same instant. Is that clear? Are you able to get me or not? Is this perfectly clear? Okay, so to discuss basically in a much more greater sense, in a very good way, what we are going to do is we are going to understand that how these things are practically possible. So the examples of one-dimensional body are, we can consider a rod, void or not. So a straight rod is the best example of a one-dimensional body. But one thing is also there that we call it as a ring. That if you look into the ring is also that same kind. Like if I have a rod and if I bend it in a circular form, then it will change to a ring or not. Yeah. So definitely a ring is not a surface kind of body because the arrangement of particle is in one dimension. So that is why a ring is also considered to be a one dimensional body. Are you able to get me or not? But geometrically, uh-huh. It is a bended rod. So that is why we see it as, we call it as one dimensional. Yeah. Example of surface kind of body are like you can take a rectangular or a square seat. Disk is an example of two-dimensional body. But then there comes an exception. Look over a hollow cylinder. If it is a hollow cylinder, and if I cut it at one part, and if I spread it, it will change to a rectangular seat or not? Tell me. Yeah. So basically, the examples of 3D hollow objects, all those 3D hollow objects are example of 2D materials. They are not the example of 3D materials. Are you able to get me or not? So that is why many people think that 3D hollow objects will be considered under the three-dimensional bodies, but they are not three-dimensional bodies. They are basically which kind of bodies? Hmm. They are basically the two-dimensional bodies. And volumetric, we have only one example: 3D solid objects. Is that clear? And this arrangement of particles actually uh, visualizes different formulas also. So that is why we have different formulas of density. Like why I separated the whole body in three different types, because to consider three different types we should have a formula, isn't it? And that formula is provided by the density. So for linear bodies we have linear density function, right or not? And we call this as linear charge density or mass density. Got it? So those kind of linear rod in which, like a rod having charge conductor, we will not use surface density or volumetric density. We will use linear charge density, and that is denoted by lambda. कैसे से denote होता है ये? And this is exactly equal to total charge by length, because here for linear bodies the volume is similar to length, because in another direction the particles does not exist. Are you able to get me or not? So density is equal to mass by volume, isn't it? But when I ask many people that what is the definition of volume, they tell that volume is nothing but a space or something like that. Okay. So many people think like that. Okay. But actually, if we think of a particular hour, linear charge density means lambda, if we think of a straight rod, तो उसमें तो भाई ब्रेथ और हाइट में तो कोई पार्टिकल ही नहीं है ना, सिर्फ लेंथ पर पार्टिकल है. तो इसीलिए हम वॉल्यूम को डिफाइन करते हैं. तो वॉल्यूम इज दैट स्पेस विच इज ऑक्युपाइड बाय द मैटर, नॉट अ स्पेस, इट्स द स्पेस विच इज गोइंग टू बी ऑक्युपाइड बाय द मैटर. सो अगर हम लीनियर रॉड को देखें तो द मैटर ऑक्युपाइज ओनली लेंथ, सो दैट्स व्हाई वॉल्यूम इज इक्वल टू लेंथ, एंड दैट्स व्हाई वी डिफाइन लीनियर चार्ज डेंसिटी एज चार्ज बाय लेंथ. Yeah, so linear charge density is equal to total charge by length. Now, for a straight rod, I can have a very small charge also or not. So density should not change. So it should be also equal to dl. Got it or not? So a small charge by small. Yes. सौरभ जी जरूर मिलेगा. अपन प्लान कर रहे हैं कुछ ऐसा लॉन्च करने का. बाई 2 और 3 days जरूर मैकेनिक्स की एक कोर्स आएगी. ठीक है. So look over here. अब ध्यान से देखते हैं. Let us look into the surface kind of bodies, and which we call it as two-dimensional body, which is denoted as, इसके लिए अपन डिफाइन करते हैं, हाँ, सरफेस चार्ज डेंसिटी. ठीक. अच्छा, सरफेस चार्ज डेंसिटी को अपन डिनोट करते हैं क्या चीज से? सिग्मा से. क्या चीज से डिनोट करते हैं? अभी 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 हमें मालूम चला कि वॉल्यूम जो होता है दैट इज द स्पेस ऑक्युपाइड बाय द मैटर. लेकिन सरफेस काइंड ऑफ बॉडीज में जो स्पेस ऑक्युपाइड है वो अपन का एरिया है, वॉल्यूम तो नहीं है ना. तो इसीलिए हाँ, इसीलिए सरफेस चार्ज डेंसिटी इज डिफाइंड एज चार्ज बाय सरफेस एरिया, because volume is exactly similar to surface area for these kind of bodies. Are you able to get me or not? Is that clear? And that means if I have a smaller area, the density should also remain same. So it is given as dq by dA. Is that clear or not? Now, for volume, total volume solid objects, there is no such change. We have a direct formula and we call it as volume charge density. And that is denoted as rho. क्या चीज से डिनोट करते हैं? रो से. और ये तो सिंपल है, वॉल्यूम 3D ऑब्जेक्ट्स में तो वॉल्यूम इज एग्जैक्टली इक्वल टू वॉल्यूम. सो दिस इज व्हाई वॉल्यूम चार्ज डेंसिटी रो इज इक्वल टू आपका क्या हो जाएगा? Q by volume. And if I have a smaller charge in the smaller volume, so it will be written as dq by dv. क्या लिखा आ जाएगा? dq by dv. Is that clear or not? Are you able to get me? So these are the distributions which we utilize in the whole of physics course uh, till end, means till your 12th hours. This whole thing which I have taught today in this board is going to be utilized. Are you able to get me or not? Is that clear? Okay, so I'll show you how to do these calculations. So means today is like a basic course which I am setting up for the whole physics course. Okay. So let's take an example. Like so, should we take an example or should we go with the? I think the charge distribution is clear to you now. We will not take only one example. We will take the generalized case of continuous charge systems. Void or not? Okay, directly. So let's suppose if I have means if I take continuous charge system, generalized, sorry, generalized concept for continuous charge systems. ठीक है. So, you have a quick revision of this particular thing and then we'll move ahead. Okay. ठीक है. चलो आगे बढ़े. देखते हैं जनरलाइज कॉन्सेप्ट फॉर कंटिन्यूअस चार्ज सिस्टम. अब मान लो आई हैव अ कंडक्टर. अब कोई भी एक बॉडी है, जनरल बॉडी है, ठीक है ना, जनरल पर्टिकुलर बॉडी which has the charges on this whole body. Got it or not? It is charged basically. अब हमें मालूम है कि this charge will be spreaded on this body or not, isn't it? Or it can be also on the surface. It depends upon which kind of body you are taking. Got it or not? Now, I told you that find the electric field over here. Now you see that if I select some random charges, if I select the charge over here, if I select the charge over here, if I select the charges these like this way, then for each of these different charges, I'll get a different electric field at this point P or not. अलग अलग मिलेगा इलेक्ट्रिक फील्ड है कि नहीं. एक का ज्यादा होगा, एक का कम होगा, एक अलग अलग होगा. तो एक means if I just write for one single charge, then it will be a very wrong idea, isn't it? So people thought that how to write it. Since for each and every charge there is a variation, so what they thought that let us define a small charge in it. What we define? dq. Yeah, we define a small charge in this whole body and we call that as dq. And then we told that this dq is located at some distance r from the considerable point which we are going to consider. Are you able to get me or not? Yes. Now they told, next thing they told that हम मतलब उन्होंने सोचा कि अगर इस पूरे बॉडी को ऐसा काम करते हैं, इस पूरे बॉडी को इनफिनाइट नंबर ऑफ डीक्यूज में डिवाइड कर देते हैं. क्या चीज में डिवाइड करता है? इनफिनाइट नंबर ऑफ डीक्यू. एंड इफ आई कैन फाइंड द इलेक्ट्रिक फील्ड बाय वन डीक्यू and then means if I just add them all other electric field into all other dqs, then I'll get the electric field into the whole body. Or so this was their concept. What was the concept? That divide the whole body into a smaller infinitesimal charges. So let us suppose, that is why I write this statement. Let us suppose infinitesimal small charge dq is located at r distance away from point P. ठीक. और ऐसे हमें क्या करना है? हमें क्या करना है? ऐसे सारे dqs का हमें सम लेना है कि नहीं? तो if I can write the electric field due to a small dq, तो वो electric field क्या होगा? Very small electric field which we call it as d. क्या लिखते हैं अपन इसे? d. That will be equal to how much? K into means 1 by 4 pi epsilon naught dq divided by r square r cap. This will be my particular small electric field due to the small charge or. And I want to find the total electric field. So what I should do? To find the total electric field, you should add all those electric field. To add, the easiest task is by the method of integration. So I'll write this as integral over whole body, and 1 by 4 pi epsilon naught is written as k. So k into dq by r square r cap. If I do this, then definitely I'm going to get the net electric field of the body at point P. Are you able to get me or not? And this is my generalized concept. So what is your generalized concept? Definitely consider a small charge system. What you have to do? Consider a small charge system. Are you able to get me or not? Okay, so let us start by taking the first generalized case. Okay, and we call that as uniform rod. Okay, They have taken uniform rod or ring. Okay, so give the heading, write it. Should I do the derivation or should I write it directly? That's a big question. Okay, let us do it. So the first case is of uniformly charged straight wire. Uniformly charged straight wire. Got it? Okay, so we'll do the derivation and then we'll move ahead. Okay, 1 minute, just 1 minute. Okay, so let's suppose I have a uniformly charged straight wire. Let us take a diagram for that. Yeah, this is my uniformly charged straight wire. मान लो इसके ऊपर कौन सी चार्ज है बेटा? Positive charges are there. Okay, so this is my uniformly charged straight wire, and I want to find the electric field at point P over here, which is located at some distance r from the straight wire. Right or not? So how to calculate that? That's a big question or not? Yeah, so right now we learned that for generalized case, first thing we have to identify which kind of body is it. So a straight wire is it's a linear body, isn't it? Then if it is a linear body, the second task is to construct a small charge in it, isn't it? Second task क्या है कि भाई इसमें एक मानना पड़ेगा dq. क्या मानना पड़ेगा बेटा? अरे कुछ तो बोलो, क्या मानना पड़ेगा? dq, जिसकी लेंथ कितनी होगी? dx, isn't it? dx मान लेते हैं, isn't it? The length will be how much? dx. तो सबसे फर्स्ट टास्क एनी जनरलाइज सिस्टम में, मतलब हमने क्या सीखा कि सर अगर कोई भी कंटिन्यूअस बॉडी है तो कंटिन्यूअस बॉडी के लिए सबसे पहला काम है दैट कंस्ट्रक्ट अ स्मॉल चार्ज विद सम ऑफ इट्स एरिया लेंथ और व्हाटएवर काइंड ऑफ बॉडी इट इज, and then just locate it. This, you know that this is located at some distance, sorry, this is located at some distance x from the center, isn't it? तो मान लेते हैं कि this is located at some distance x. Got it? And then we will proceed with the calculation. Now we can proceed easily, है ना? तो अब कैसे बढ़ेंगे? अब देखो, अब एक मतलब एक कॉन्सेप्ट आता है बेटा कि या तो तुम पूरे रॉड के लेंथ को कंसिडर करो, but then it is a tedious task. The one thing, one of the most easiest tasks to consider the length is by taking the angle. जैसे मान लेंगे कि जिस आर पे ये पूछ रहा है ना, ऊपर का एंगल सबस्टेंड जो हो रहा है एंड तक वो मान लेंगे अल्फा, और नीचे का जो एंगल सबस्टेंड हो रहा है आई विल कॉल दिस एज बीटा. क्या बोलूंगा इसे? Alpha and beta. See, the point is very very simple. See, I have a whole length of the rod, but then considering every point, adding them together, it's a very tedious task or not. So why not, with respect to point, just consider the end and draw the angle, because angle will give also the same idea, isn't it? So you can consider the length also, you can consider the angle also. So the most easiest technique which we will follow is our angle. So let's suppose the two ends of the rod are located at some angle alpha and some angle beta. Are you able to get me or not? Is that clear? Now, due to this dq, there will be some charge, there will be some electric field at point P or not. And that electric field will be, since this rod is made up of positive charges, so this electric field will point in this direction. I call this electric field as D. क्या बोलूंगा इस electric field को? अरे कुछ तो बोलो. हाँ यार. Is that clear? 1 minute, let me erase this. Okay, I'll call this as D. See, so let us make the statement. Let the ends of rod makes an angle uh, alpha and beta at point P for top and bottom end respectively. ठीक है? First statement. Second statement, let dq be a small charge located at distance x from, मान लो ये पॉइंट का नाम है O, from O, and it creates an electric field D at point P. So these are two statements at point P. Are you able to get me or not? Is that clear? Okay, so can we move ahead now perfectly? तो ध्यान से देखो, अब सोचो जरा, मान लेते हैं कि ये तो एंगल हमें पता है कि दिस एंगल इज बीटा, isn't it? But the angle which this dq is making with r, I call this as angle how much? Theta. I call this as angle how much? Theta. Is that clear or not? That's my theta. Are you able to get me? Now look over here. Due to that angle theta, this means that this d, if this angle is theta, then this angle is also theta. So then this d has two components. One is along the parallel line of the rod and along the perpendicular line of the rod. And if this angle is theta, तो भैया ये हो जाएगा तुम्हारा वैल्यू d cos theta and d sin theta. Are you able to get me or not? अच्छा, ये जो रेड यहाँ से लेके ये जो डिस्टेंस है, ये वाली डिस्टेंस जो होगी, दिस रेड लाइन वाली डिस्टेंस, इज दिस डिस्टेंस इज नथिंग बट रूट ओवर r square plus x square, isn't it? So मैं लिख देता हूँ, लेट सपोज द डिस्टेंस between dq and point P is equal to how much? Root under r square plus x square. So all the statements are complete, all the diagrams are complete. If you have any kind of doubt, please tell. ध्यान से देख लो एक बार. बताओ. dq is my this charge. So distance between this dq and this point P is how much? Root under r square plus x square. ठीक है? तो ध्यान से देखा जाए, अब पॉइंट आता है कि हम इस dq की वजह से इलेक्ट्रिक फील्ड निकालेंगे तो कितना है. तो सिंपल, फॉर dq द इलेक्ट्रिक फील्ड विल बी हाउ मच? 1/4 pi epsilon naught dq divided by r square plus x square. Sorry, distance is root over r square plus x square. So root over r square plus x square का होल स्क्वायर, यही होगा ना इलेक्ट्रिक फील्ड dq की वजह से, है ना? तो ये इलेक्ट्रिक फील्ड की वैल्यू कितनी आई? 1/4 pi epsilon naught dq डिवाइडेड बाई r स्क्वायर प्लस x स्क्वायर. देखो हमने पहले ही बताया जनरलाइज्ड केस में कि सबसे पहले dq डिफाइन करो, dq की वजह से डिस्टेंस पता करो पॉइंट p का जहां पे इलेक्ट्रिक फील्ड निकालना है. थर्ड स्टेप अप्लाई करना है कि d निकालो और उसके बाद इंटीग्रेशन लगाओ, तभी इंटीग्रेशन लगा सकते हैं कि नहीं? Yes, but right now this d has two component. One is parallel component and another one is perpendicular component, and one is d perpendicular, isn't it? So with a rod, remember that whenever there is a rod and this point, this particular origin O is not a perpendicular bisector, then this DE has two components. One is parallel and one is perpendicular. If this is a bisecting point, then D parallel is exactly equal to how much? 0. Are you able to get me or not? Remember, see, मतलब समझो जरा, खुद सोचो. अरे भाई, अगर मान लो एक परपेंडिकुलर बाइसेक्टर है ना, तो इलेक्ट्रिक फील्ड के दो कंपोनेंट्स होंगे, इधर साइड वाले की वजह से ऐसा और ऐसा. लेकिन इसका एक वाइस वर्सा इमेज भी तो होगा, उसकी वजह से क्या होगा, उसके वजह से भी जो इलेक्ट्रिक फील्ड आएगी उसके दो कंपोनेंट, एक ऐसा और एक ऐसा, तो पैरेलल वाले कंपोनेंट कैंसिल हो जाएंगे ना. Parallel components will cancel if the rod is divided perpendicularly, and if the rod is not divided perpendicularly, then the parallel component will never ever cancel. अरे कुछ तो बोलो यार. हाँ है ना. मैं फिर से बता दे रहा हूँ. मान लो अगर ये रॉड है, ठीक है, और इस रॉड को अगर अपन ने बीच से काटा और यहाँ पे एक चार्ज लिया dq, उसके वजह से यहाँ पे इलेक्ट्रिक फील्ड निकाली, तो उस इलेक्ट्रिक फील्ड के दो कंपोनेंट्स होंगे, एक ऊपर की ओर और एक इस साइड में, है ना. लेकिन उसी dq का एक दूसरा इमेज भी होगा, उसकी भी एक इलेक्ट्रिक फील्ड होगी इस डायरेक्शन में, और उसका भी एक कंपोनेंट ऊपर होगा और एक राइट हैंड साइड होगा. लेकिन अगर हमने इक्वली डिवाइड किया, इफ दिस डिवीजन इज टोटल इक्वली, the amount of dq on this side and amount of dq on this side is same. So उसके वजह से इधर का इलेक्ट्रिक फील्ड और इधर का इलेक्ट्रिक फील्ड इक्वली अपोजिट एंड सेम होगा, and that will be equal to how much? 0. Are you able to get me or not? And if it is an uneven distribution, then इधर का dq ज्यादा होगा, इधर का dq कम होगा, तो इधर की इलेक्ट्रिक फील्ड ज्यादा, इधर की इलेक्ट्रिक फील्ड कम, तो वहां पे पैरेलल इलेक्ट्रिक फील्ड एग्जिस्ट करेगा. इज दैट क्लियर और नॉट? Got it? Okay, so let us do the calculation. We will first do the calculation. So let us do the calculation. What we are planning, that we will do first the calculation for the parallel component. किस component के लिए? Sorry, perpendicular component. Now अब ध्यान से देखो, तो इसमें हमारे पास dq का कुछ वैल्यू थोड़ी ना पता है ना. So question arise होगा ना कि what is the value of dq, how to find it. Then our this idea of continuous charge distribution appear, जो ये अभी मैंने बताया कि कैसे हम डिवाइड करते हैं. तो सर एक बात मान लो, अगर रॉड दिया हुआ है और रॉड के ऊपर पहले से टोटल चार्ज q था और लेंथ ऑफ द रॉड कितना था? l. Got it? So let's suppose I'm writing it that if length of rod was L and it has charge how much? Q. Then I can, and we know that a rod is a linear body. So I can apply directly linear charge density or not. So lambda will be equal to how much? Lambda की वैल्यू क्या हो जाएगी? Simple. Sir, it is पहले dq होगा क्या? It will be equal to total charge by total length. And that is equal to a small charge by a small length. And a small charge का length क्या है? dx. Isn't it? So here we are aware of what? Here we are aware of q and l. So I can write dq in terms of q and l, and this dq can be written as q by l into dx. Are you able to get me or not? So this is what we need to understand. In some of the books, you will see that q and l is not given. Means they tell that the rod has uniform charge density lambda. So over there dq is written as lambda dx. Are you able to get me or not for the rod? ठीक, क्योंकि ये तो नहीं रहेगा ना वहां पे. ओके, ध्यान से देखो, परपेंडिकुलर कंपोनेंट क्या हो जाएगा? परपेंडिकुलर ई परपेंडिकुलर हमें निकालना है, सो दैट विल बी इक्वल टू इंटीग्रल ऑफ ऑल दोज स्मॉल परपेंडिकुलर कंपोनेंट्स. सो डी ई परपेंडिकुलर इज, डी परपेंडिकुलर क्या होगा? सिंपल, डी ई का वैल्यू परपेंडिकुलर की तरफ व्हिच इज डी cos थीटा. सो आई विल गेट ओवर हियर 1 by 4 pi epsilon naught. I'll write it as k into dq. Dq is written as q by L into dx by r square plus x square and into cos theta. This will be my whole term, isn't it? मेरे कुछ तो बोलो हाँ या ना. ठीक, आगे बढ़े. अब ध्यान से देखो, एक और एनालॉजी को देखो. तो हम यहाँ पर अगर हम tan थीटा अप्लाई करें तो tan थीटा इज एग्जैक्टली इक्वल टू हाउ मच? Perpendicular by x by r, isn't it? So x can be written as what? R tan theta. So I can write now dx is equal to how much? R is a common, R is a constant. So it will be changing to sec square theta into d theta. Are you able to get me or not? So if I apply this over here as dx, because here are two variables x and theta, so I must convert one of them into theta, isn't it? So I'll write E perpendicular as, this term will be reduced to kq by L outside dx is r sec square theta d theta into cos theta divided by r square plus x square. So x square is how much? R square tan square theta. I'll take r square common, 1 plus tan square theta. Is that clear or not? And 1 plus tan square theta is also sec square theta. So this whole term got cancelled or not? And r got cancelled. So what I am left with, E perpendicular is equal to kq by L integral cos theta by r. R is also constant, so it will be coming outside, cos theta into d theta, isn't it? अरे कुछ तो बोलो यार, हाँ है ना. अब ये डी थीटा जो है वो कहाँ तक वैरी करता है? सिंपल सी बात है, ये थीटा की वेरिएशन जो है वो नीचे की ओर, मतलब माइनस बीटा से लेके पॉजिटिव अल्फा की ओर है ना. तो this integration will be taken from minus beta to alpha, and E perpendicular का इससे वैल्यू आया kq by lr. cos का इंटीग्रेशन होता है साइन, तो साइन अल्फा माइनस ऑफ माइनस साइन बीटा, तो वो चेंज हो जाएगा प्लस साइन बीटा. इज दैट क्लियर और नॉट? इज दैट क्लियर? नाउ you can apply this whole same trick. We can even apply, इसको और छोटा करूं या नेक्स्ट पेज ले लूं? Let us consider the next page, isn't it? So we have till now we got dq for perpendicular. For parallel case, for parallel component, sorry, so means electric field will be integral of E parallel will be integral of the parallel component, which is d sin theta, isn't it? It will be parallel component of d sin theta, isn't it? So d we will write, it is equal to integral 1 by 4 pi epsilon naught dq by r square plus x square into which theta? Sin theta. Once again, I'll write dq in terms of dl and all. So E parallel can be written as integral dq is q by L into dx r square plus x square into sin theta. And I can take kq by L common, isn't it? Dx, once again I can substitute this whole term over there, isn't it? X is equal to r tan theta and all. So if I replace x is equal to r tan theta and all, then I'm going to this, once again this 1 plus tan square theta will come and they will get cancelled, and I'll be left over here as 1 by r into sin theta d theta, isn't it? So I can show you. So dx is what? R square sec square theta d theta. Sorry, not r square, r only. And then r square plus x square is nothing but r square common, 1 plus tan square theta, and this is my sine theta. So once again you will see that this and this got cancelled, r and r got cancelled, and I'm left with integral, sorry, kq by lr outside integral sine theta d theta, isn't it? This is my term. Now look over here. This one's this also, this whole term kq by lr sine theta d theta varies from minus beta to alpha. In integration of sine theta is what? Minus cos theta. It will be minus cos theta now. Yes. So what I'll be left with? I'll be left with kq by lr minus cos alpha plus of cos of minus beta. And cos minus theta is simply theta. So E parallel is given as kq by lr cos beta minus cos alpha. Here it is sin beta plus sin alpha. Here it is cos beta minus cos alpha. Are you able to get me on it? Where beta is the downward angle. Which angle? Downward angle. Is that clear? Are you able to get me? So this is the electric field. Now we know that specifically lambda is written as Q by L, isn't it? So wherever in question we if the charge density is given, replace Q by L as lambda. Is that clear or not? So let us have quick check, a quick check for that, and we'll write we'll write the answer that if I have a rod, 1 minute. If I have any kind of a rod which is positive charge in nature, okay, positively charged rod, and I want to find some electric field at a distance r, not from the origin of the rod, not from the center of the rod, at some random distance, then the ends will sustain and our and ends will create the upper angle alpha and the downward angle beta. Then at this point I'll have two components of electric field, one parallel component and one perpendicular component. Is that clear? Remember that we'll tell last point. This is my point P. So parallel, this is my perpendicular, and it is given as, if the lambda is given, then it is k lambda by r sine alpha plus sine beta. So there is no problem in writing perpendicular component. But when we are writing parallel component, you have to always see the sign. So it is written as, see that E parallel is written as k lambda by r cos beta minus alpha. So so remember that the opposite means if the beta is taken in downward direction, the parallel component will be opposite of beta. Are you able to get me or not? If beta is taken in upward direction, like this way, then the parallel component will be in downward direction. Is that clear or not? That's how you need to identify parallel component. Is that clear or not? And if the total charge is given on the rod and length of the rod is also mentioned, then remember to use lambda is equal to Q by L. And this is the electric field for any random point of uniformly charged rod. Yeah, you can find the resultant of parallel and perpendicular, but that is a totally tedious task because you'll have to take the square of these two and then you'll have to add. So once again, that's a very much tedious task. Yeah, yeah. Okay, is that clear? Can we move to next point? Okay. Now this was for the charged rod. So we did the first case of generalized linear charged rod, isn't it? Now there are some cases over here. Let us understand that. Okay. The first case, case one of a charged rod is if the rod is infinite. Got it? Huh. Acha, you asked me now that what will be the resultant or something like that, isn't it? Hello, can you hear me? Yeah. So you asked me that what will be the resultant and all, isn't it? So yeah, let me. I have the formula for that also. So let's suppose the resultant will be in this direction. Got it or not? So then this resultant, I write it as E. So E will be nothing but root under E parallel square plus E perpendicular. But one thing is there that this will be present at some angle phi or not. This will be means yes. So the question arises that what is this angle phi? Okay. So if angle phi is known to you, then E parallel is very easy to calculate, isn't it? So to calculate that, if you write, see, if I take tan phi, see that if I take tan phi, then tan phi will be perpendicular by base, isn't it? Perpendicular is E parallel and base is E perpendicular. Yes. E parallel k lambda by r and k lambda by r will get cancelled and I'll be left with cos beta minus cos alpha divided by sin alpha plus sin beta, isn't it? And you can solve that. This is like this follows a trigonometric ratio like 2 sin alpha plus this can be written as cos alpha minus cos beta will be written as 2 sin alpha plus beta by 2 into sin alpha minus beta by 2. Okay. No, it will be alpha minus beta. I'm perfect. I'm correct. Okay. Hmm. And then and then uh, next thing will be I can write this as 2 sine. This will be written as what? So one thing is there. One thing is there. Is just 1 minute. This E parallel which we are taking is little bit diametrically wrong. Okay. Yeah. The point is this will not be in this direction. Yeah. क्योंकि ध्यान से देखना जो हमने DQ लिया है ना वो नीचे की डायरेक्शन में लिया है कि नहीं तो बीटा की वैल्यू पॉजिटिव होगी और अल्फा की वैल्यू नेगेटिव बट हमारा रेफरेंस बोलता है कि हम इसको माइनस मानेंगे इसको प्लस मानेंगे तो माइनस थीटा पे हमारा इंटीग्रेशन होना चाहिए ओके तो इसीलिए ये याद रखना हरदम कि जिस डायरेक्शन में आर एबल टू गेट मी और नॉट I'll tell you see I did the integration with a reference point that downward is negative and upward is positive or not. So here the theta which I am considering that should be also taken as negative, isn't it? But I am generally considering only theta. So that is why it should be present in the downward direction. Yeah. So we are not taking minus theta the integration. So that's why we will write at the end that in the direction of beta only the E parallel component will be there, and the formula will be given as simple. हाँ साइन को तो ध्यान में रखना होगा ना. Lambda is, if lambda is equal to q by L, then it is written as E parallel equal to k lambda by R cos beta minus cos alpha. So in the same direction of beta, if you write cos beta minus cos alpha, then it is in the same direction. And if you write cos alpha minus cos beta, then it will be in upward direction. Okay, is that clear or not? And then our net electric field will be in this direction. This is my E resultant, which makes some angle phi with the our base. Okay. So now look over here. When we use this, so this is 2 sine alpha plus beta by 2 sine alpha minus beta by 2. And this is 2 sine, what it will come as? Alpha plus beta by 2. Cos alpha minus beta. तो ध्यान से देखो ये कट जाएगा, बचेगा क्या? 2 2 भी कैंसिल. It is exactly equal to tan alpha minus beta by 2. So did you got one idea that phi is nothing but it is alpha minus beta by 2 directly, and that's how we will get the answer. Are you able to get me or not? So if it is a straight rod, perpendicular component is k lambda by r sin alpha plus sin beta. Parallel component is k lambda by r cos beta minus cos alpha, where cos beta means the electric field is present in the same direction of beta. Are you able to get me or not? And then the resultant E, which makes angle phi with the perpendicular component, is given as alpha minus beta by 2. Are you able to get me or not? Is that clear? चलो तो आगे बढ़ते हैं. Let us take the generalized case, special cases of it. The first case is if the straight rod is infinite. If the straight rod is what guys? Infinite. अच्छा अगर straight rod infinite हो गया तो तुम खुद सोचो what will happen. तुम खुद बताओ क्या हो अगर मान लो ये स्ट्रेट रॉड इनफाइनाइट इंफिनिटी तक जा रहा है. ओके अच्छा you only tell me if the straight rod is infinite and I want to find the electric field at point P which is located at some distance r from the rod, then एक बात बताओ बेटा, ये जो एंगल जो इसके एंड तक सब्सटेंड करेगा, दिस एंगल अल्फा एंड बीटा which will go till infinity, isn't it? This alpha and betas which will go till infinity, what will happen with them? ऐसा लगेगा कि नहीं कि ये basically this alpha is increasing suddenly and it will become perpendicular perfectly at infinity, isn't it? है कि नहीं? मतलब तुम ही सोचो, देखो पहले एक छोटा सा रॉड है तो ये एंगल कुछ इस तरह से बनेगा, फिर थोड़ा सा बड़ा हो गया तो ये एंगल ऐसा, फिर थोड़ा बड़ा, फिर तो देखो ध्यान से ये क्या होते जा रहा है, परपेंडिकुलर होगा या नहीं होगा? तो at infinity the angle means if the rod is infinite the alpha and beta changes to what? Infinity. Angle 90 degree. Got it? So for infinite rod alpha is equal to 90 and beta is equal to how much? 90. Alpha is equal to beta is also, we have already taken the sign convention, then only we are getting this terms. Okay, so beta is also how much? Now look over here. Parallel component is cos term. So cos 90 and cos 90 is how much? 0. So for a straight rod, parallel component is 0. Only which component exists? Perpendicular. And that is equal to sin 90 plus sin 90. This is sin 90 plus sin 90, which is twice k lambda by r. If lambda is given, it is equal to twice k q by lr if q is given, and k means it can be written as 2q by 4 pi epsilon naught lr. That is my full formula of straight infinite Wrong. Are you able to get me or not? E parallel is how much? 0. Because E parallel has a formula k lambda by r cos beta minus cos alpha. And E perpendicular is k lambda by r sin alpha plus sin beta. है कि नहीं? पूरा कॉन्सेप्ट क्लियर हुआ? नेक्स्ट पॉइंट, और कुछ एक और पॉइंट ले सकते हैं. लेट सपोज इफ इट इज अ सेमी इनफाइनाइट वायर. सेकंड केस, नो, या फॉर सेमी, या फॉर सेमी इनफाइनाइट वायर. Okay, means if the wire is not going till infinity, so this is my wire and it is going till infinity in only one direction, but over here it is stopped. Right or not? So I'm not asking, listen, I'm not asking the electric field from the center. I'm asking from this end at point P, which is located at some distance r. So look over here. If you see that, then this angle alpha over here, since at the top it is going till infinity, so angle alpha will be once again 90, while beta will be exactly equal to 0 or for semi infinite wire, alpha will be how much? 90 and beta will be. Then if we write, the particular electric field parallel component, so E parallel will be how much? E parallel is written as k lambda by r. Sorry, if the rod is having lambda, cos बीटा माइनस cos अल्फा. तो cos अल्फा तो जीरो हो जाएगा, बट cos बीटा 1 होगा ना. तो क्या आएगी? k lambda by r as it is, isn't it? अच्छा, E परपेंडिकुलर क्या होगा? It is k lambda by r sin अल्फा प्लस sin बीटा. तो एक की वैल्यू 1 होगी और दूसरे की वैल्यू 0, तो once again I'll get how much? K lambda by r. So that means the electric field over here has two components, one perpendicular and one parallel, isn't it? So E parallel, 1 minute, this E perpendicular is also k lambda by r and E parallel is also k lambda by r. So that means the resultant E will be present in, yeah, so E resultant will be root 2 k lambda by r. Is that clear? Or are you able to get me or not? And this angle will be how much? 45 degree. Achha, there was one question in your NCRT that for infinite and semi-infinite cases, for infinite and semi-infinite cases, can we use basically lambda is equal to q by l? बताओ. For infinite and semi-infinite wire, can we use lambda is equal to q by l? Yeah, actually, see, this is why one more thing. This was your one more question, means one more way that why we brought the concept of continuous charge distribution. That for infinite rod or semi-infinite rod, if you use only simple charge, then length is still infinity. So electric field will be infinite. But the answer is at any, listen, yeah, at any random point, if we consider, then electric field is never ever infinite. It is a finite value, means it is a saturated value. Right or not? So electric field is not infinite for any case. Okay, you can't produce an infinite electric field. Okay, is that clear? Now? So this is why we can't use for the infinity our Q by L form or something like that. Is that clear or not? Only we can use lambda. So just linear charge density will be given to you. Just use the density term, but do not use Q by L because L is infinite. So this is why we brought the density, because the whole question can be divided, whole thing can be turned in the terms of density. Okay, is that clear? So we have the normal case of rod, then we have the infinite, then we have the semi-infinite. But then there is one more case which we need to address, that what if for the rod which you are considering, beta, if your point of interest is somewhere over here, which is located, which is still located at some distance r, but there is a gap of some distance x from one end of the rod. So the point is still I can write this in terms of beta and alpha by considering top and end. But the angle subtended will be something like this way. This will be your beta and this will be your alpha. And this is a positively charged rod with lambda as uniform charge density. Are you able to get me or not? Then once again also the electric field will be only present in two directions. One will be the perpendicular electric field and one will be the parallel electric field. Void or not? But E perpendicular has the same formula still, which is k lambda by r. Sorry, it has a different formula this time, k lambda by r sine alpha minus of sine beta. Got it? Instead of plus this time, this is what? Minus, and E perpendicular and E parallel. How it is minus? Right. Previously we considered minus beta. So we got positive term over there. And this time E parallel will be how much? K lambda by r. But since minus beta can't be changed in cos, so it will be cos alpha minus cos, sorry, cos beta minus cos alpha. Is that clear or not? Are you able to get me? Okay. So do you want to do some question? Okay. Do it. Bol raha hai. If there is a uniform rod, okay, and at point A, if the ends of the rod make, this is 53 degree and this is 37 degree, and the rod has linear charge density as lambda plus lambda, and this distance is given as r. Okay, and this is my point P. Then find E at point P. बताओ क्या होगा आंसर? Yeah. Yeah, you have to do that. Simple. So look over here. Once again, I'll have perpendicular component and parallel component. First, find perpendicular and parallel. ठीक है? परपेंडिकुलर में क्या होता है? फॉर्मूला k lambda by r अल्फा प्लस साइन बीटा क्या हो जाएगा? k lambda by r sin 53 plus sin 37, isn't it? So which is how much? Sin 53 is 4 by, okay, and sin 37 3 by. So this is how much? K lambda by r 7 by 5. 7 by 5 k lambda by r, isn't it? Achha, is this E perpendicular is along the I cap direction? Along I cap direction or not, isn't it? Similarly, I can find E parallel. Yeah. So k lambda by r cos beta minus cos alpha. This is my term. So k lambda by r cos beta is how much? Cos 37, because this is going to be beta and this is going to be my alpha. So cos 37 minus cos 53. Are you able to get me? So this is how much? K lambda by r. Cos 37 is how much? 4 by 5 minus cos 53 3 by 5, isn't it? But this is along minus j cap, isn't it? So this is how much? K lambda by 5. So this is 1 k lambda by r, 1 by 5 k lambda by r. I'll erase this 1. Okay. Uh, so E parallel vector is uh, k lambda by 5r minus j cap. अच्छा हमें मालूम है कि जो रिजल्टेंट है, the resultant will be in some random direction, and that resultant will have some angle phi over here, isn't it? That phi will be given as what? Alpha minus beta by 2, isn't it? Alpha is 53, beta is 37, divided by how much? 2, isn't it? Yeah, so this is electrostats. This is we are completing electrostats, and we are trying to find the generalized electric field for different cases like rod or something like that. Okay, we are calculating electric field, isn't it? That's an awesome thing. So this is how much degrees? Phi is how much degrees? 8 degrees. Is that clear or not? So we did first case, like we had semi-infinite, then infinite, then we had a generalized idea, third case, and then before that we did the derivation and all of these, isn't it? Now I'll give you a mixed question out of it. Okay, So look over here. Let's suppose a charged straight rod which is semi-infinite. कैसा है बेटा? Yeah, it is semi-infinite. Okay, and I want to find the electric field in which one of the end makes 37 degree over here. Okay, and it has the charge density as lambda. Right or not? This wire is semi-infinite. One end is making 37 degree, and if this distance is r, then find the electric field at point P. Sorry, r no. R. Then find the electric field at point P. Find the electric field at point P if the rod is uniformly charged and it is semi-infinite. Now, do it fast. You have last 2 minutes. It's a very nice question. Okay, means you have to just analyze it. There is no big conclusion over here. Achha, if it is semi-infinite, we know that. See, I know my beta. Like we can apply the generalized idea of this question, isn't it? I need beta and alpha. So beta I am already aware of, which is 37 degree. But what is alpha? Alpha is simple. Yeah, if it is infinite, then alpha is another end is infinite now. So alpha is 90 degree. So here we have alpha is equal to 90 and beta is equal to 37. Isn't it? That's all. Then we can apply the direct formula of this question or not. That okay. So this is E perpendicular and this is E parallel, isn't it? So E perpendicular will be how much? E perpendicular in this case is written as k lambda by r sine alpha minus sine beta, isn't it? That's what that is what is our formula. So this is k lambda by r sine 90 minus sine 37 I cap, isn't it? If it is a vector quantity. Are you able to get me? So this becomes how much? K lambda by r sine 90 is 1 and this is 3 by 5 I cap. So this is twice k lambda by 5 r I cap. Are you able to get me or not? If I write E parallel vector, then it will be k lambda by r. Parallel is not going to change, isn't it? Because, so cos 90, sorry, sorry, cos 37, sorry, cos beta minus cos alpha it is, no? We write it cos beta minus cos alpha r cap. So this becomes how much? K lambda by r. Cos beta is cos 37 minus cos 90. Yeah, so it is simply, it is 4 by 5 k lambda by r cap. Are you able to get me or not? So these are my values of E parallel and E perpendicular if I have a combination of semi-infinite and a shifted angles. Are you able to get me or not? Sorry, minus j cap, not r cap. You have to write minus j cap. If it is in the downward direction. Is that clear? Okay, so this was all about your case of rod, which we need to discuss. So this involves many different ideas. So we had a whole big of derivation. Then we considered that it has two components, E parallel and E perpendicular. E parallel is given as k lambda by r cos beta minus cos alpha, and E perpendicular is k lambda by r sin alpha plus sin beta. So this is just one cases of continuous body we did, and that is rod. We are left with ring, a square, seed, disc, and a sphere, and many different cases. Are you able to get me out? So tomorrow we'll try to complete ring and disc, and then we'll move to next day in which we will complete the sphere and cylinder, and then we will finish this particular topic and chapter. Are you able to get me or not? Okay, and then I'll be doing at the end. I'll be doing dipoles. One last class of the dipoles. Okay. Chalo. So let me just switch off the streaming. By the YouTube guys, if you'll have doubt, post it on Telegram or WhatsApp. You have everything. Like, subscribe.